Welcome back. In this video, we are going to solve a structural design problem that involves a column design using working stress method based on eStructural Design Taichi found on the App Store. Design a reinforced concrete circular column using working stress method that carries an axial load of 200 kips. Design criteria as follows. Strength of concrete 4000 psi, vertical bars 3/4 inch diameter bar grade 40, spiral tie bars half-inch diameter bar grade 33, steel ratio 3%. The column carries an axial load of 200 kips. Assume a self-weight of 2.09 kips for a total load of 202.09 kips. Enumerate input parameters required. C4 for column name, circular shaped spiral column. Second to third for column segment, 10 feet unsupported height. Vertical bars, 3/4 inch diameter bar at grade 40. Spiral tie bar, half-inch diameter bar at grade 33. Strength of concrete, 4000 psi. 3% steel ratio. Pure axial load of 202.09 kips. Given Fc prime equals 4000 psi, Fy equals 40,000 psi, N equals 8.044, M equals 11.76. The reduction factor is 0.83 and the nominal load is 243.48 kips. The gross area of column is 152.18 square inches for a diameter of 14 inches. Given Ag equals 153.94 square inches and 3% steel ratio, the area of steel is 4.62 square inches. The number of bars for 3/4 inch diameter is 11. For half-inch diameter spiral tie bars, the pitch is 2 1/8 inches. Design results in metric are as follows. Fc prime equals 4000 psi, Fs equals 20,000 psi, column size is 350 mm by 3048 mm, vertical bars of grade 40, 11 pieces 20 mm bar, spiral tie, 12 mm bars at grade 33, pitch at 53 mm on center. Thank you for watching. If you find this video helpful, please like, share, and subscribe to this channel.